Here we have our first prototype, a self-sustaining electric generator capable of generating 10 kilowatts of power, the Liberty Engine 1.0. This prototype went viral, so we're going to explain step by step how it's made and how it works. Stay until the end of the video to discover new secrets we've never revealed. To make this generator, we need a car alternator like this one. Now we're going to disassemble the pulley. This pulley has a bearing that rotates in one direction and locks in the opposite direction. We can't disassemble it. Therefore, we're going to weld this iron plate to lock the bearing. Now we can unscrew the pulley without the bearing rotating. It wasn't easy, but we've got it. We continue disassembling the alternator. This alternator is 12 volts and 100 amps. We've removed the back cover, and now we're going to remove the brush collector from the rotor. We won't need this. Now we disassemble the rectifier. The rectifier's job is to transform the alternating current generated by the alternator into direct current, which is what a car needs to charge the battery. The rectifier is soldered to the ends of the alternator coils. For this reason, we must cut them with pliers. Here you can see the ends of the 3 coils. This one, and this one. We continue disassembling the casing. We hit it with the mallet to separate the 2 parts. We continue hitting it to extract the stator winding. Later, we'll explain one of the secret keys related to the winding that we've never revealed before. We hit the shaft and extract the rotor. Now we cut these fang-shaped pieces with the angle grinder. We must modify this rotor to convert the alternator into a new, improved, high-efficiency alternator. Here are all the cut pieces. We put it in the drill press, and with the angle grinder, we reduce or smooth the cuts. Now we have it smoothed. Now we cover the surface of the rotor winding with insulating tape. Another secret we've hidden is that under this layer of insulating tape, we've placed a sheet of a special material composed primarily of silver and aluminum. We have a video about this material. It's called our gallium alpha. Now we're going to glue some neodymium magnets. We place it here and secure it with cyanoacrylate. We glue all the ones on the right side in the area where the fang-shaped pieces were. All the magnets on this side will be attached with the same magnetic orientation. Now we glue a second magnet next to each of the ones we've already attached. This process is quite complicated because both magnets repel each other. That's why, once glued, we secure them with a bit of insulating tape. We continue gluing the rest of the magnets. We've already glued the magnets on one side. Now we'll wait for the adhesive to dry. Once dry, we remove the insulating tape. This is how the magnets are positioned. To attach the magnets on the other side, we'll use another technique. First, we'll glue both magnets with cyanoacrylate and let them dry. This way, we can insert them as a single solid magnet. We'll join 6 pairs of magnets together. And now we begin gluing them on the opposite sides. These magnets are magnetically oriented with the opposite polarity to the ones we glued previously. If the previous row of magnets had a south polarity, these will have a north polarity. Here are all the magnets glued together, alternating north and south polarities. Now we're going to use an empty soda bottle to create an airtight container. We'll cut the container. We'll cut a cylinder the width of the rotor. And we'll wrap it like this. Now we'll secure it with insulating tape. Since the bottle wasn't wide enough, we needed another plastic cylinder. By joining them together, we'll create a container around the magnets. Now we cut out the gaps in the blades. Here we have them all cut out. And now we fill those gaps with hot glue. We've created an airtight, leak-proof container around the rotor magnets. Next, we'll make an epoxy adhesive mixture. The mixture will be a ratio of component A at 60% and component B at 40%. Shake to mix the components well. Pour the contents into the container we created around the rotor. Fill the container completely and make sure there are no leaks underneath. Let it dry for 24 hours. Now we can remove the container. No need to be too careful. When the epoxy resin hardens, it gives strength to the rotor and permanently secures the magnets. Using the angle grinder, we ground the surface to a precise size so the rotor would fit inside the stator. Despite its rough appearance, the technology behind it seems miraculous. Let's talk about the winding. Many have asked why a 12-volt alternator generates 220 volts. And that's because we've replaced the coil with one that generates 220 volts. That's all there is to it. Good. We continue by soldering a wire to each of the coil terminals. To do this, we use a soldering iron and solder. We insert a heat shrink tube into each of the wires to electrically insulate the connection. We heat it with a lighter flame, and the tube shrinks. Now we place one of the bearings on the rotor shaft. We've cleaned all the grease off the parts. We assemble the new 220-volt coil inside the housing. Now we carefully insert the rotor. We replace the other cover and close it. We secure the assembly with all its bolts. Now we're going to attach an electrical terminal block. To do this, we'll use 2 nylon cable ties. We'll insert each alternator cable into each of the terminals on the terminal block. We secure the cables with a few more cable ties. Now we'll install this pulley with a Type 1108 quick-release conical bushing. When these bolts are tightened, the conical bushing is inserted into the pulley, narrowing the hole. This way, the pulley is secured to the shaft. Now we'll make a part to attach the single-phase motor. We'll use this angle iron and mark the area where we'll cut the part. Using a circular saw, we cut the marked area. The part fits perfectly onto the motor flange. Now we mark the fixing holes and mark the center of each hole. We also mark these fixing holes for the part. We drill all the holes. And attach the angle iron to the motor using bolts and nuts. This is how it looks. Now we'll place this other pulley on the engine shaft. This pulley has the same number of teeth as the alternator pulley. We position it and secure it with the bolts. The engine is now ready. Now we'll make another mounting bracket for the alternator. We'll use another piece of angle iron like the one before. We trace the area we need to cut again, and cut this piece with the angle grinder. We mark the holes, and also the mounting holes. We mark the center of each hole and drill each one. Now we attach the piece to the alternator. This wooden board will serve as a base for securing all the components. Many people often accuse us of hiding batteries in this wooden base, but it's impossible for simple batteries to generate as much voltage as you'll see later. Even so, for the more skeptical, we recorded another video replacing the wooden base with a transparent one. We've marked all the mounting holes on the base. We drilled the holes and continued securing the motor to the base using bolts and nuts. We connected both pulleys using this drive belt, and in the same way, we secured the alternator to the base. This way, when the motor turns, the alternator also turns. We're going to put a Schuko plug on the motor's power cable. This is a single-phase 220-volt, 2800 RPM motor. We'll also need a multiple socket strip with a switch. We unsolder the power cable and we solder these two wires. We close the strip again and insert the two wires into two of the three alternator terminals. With these screws, we secure the socket strip. Let's check if it works. We'll wrap a cable around the alternator shaft. And when we pull the cable, we see that it works. So it's time to put it to the test. We've come to the field to test our Liberty engine prototype. We're going to connect different devices to it to check its capacity. We need to turn on this switch. If there were hidden batteries, the device would start up immediately, but it doesn't. We wrap the cable back around the alternator shaft. We flip the switch on the power strip connected to the alternator. When we pull the cable, the modified alternator begins to spin, generating 220 volts. That voltage, through the power strip, is injected into the motor. And it also powers anything we plug into the power strip, like this angle grinder. In turn, the motor, as it rotates through the drive belt, rotates the alternator, maintaining the feedback system constant and indefinitely. The Liberty Engine 1.0 emerges as a synthesis of many advances made by T. Henry Moray, Howard Johnson, and Nikola Tesla. Why don't we commercialize this generator? The Invention Secrecy Act keeps 5,784 patents under secrecy. Official data FY 2017. Most come from the energy and propulsion sectors. If a prototype threatens fossil fuel corporations, the usual route is classification and oblivion. We were able to access classified material and replicate the generator, but it doesn't belong to us. When we turn off the switch, the motor loses power and stops. Howard Johnson suffered industrial blockades. T. Henry Moray saw his laboratory destroyed. Bedini's samples disappeared at international customs. The pattern is clear. When something works, it disappears. We won't let this invention be forgotten either. If you enjoyed the video, please like and subscribe or leave a comment. You can also support the channel by becoming a member. Thanks for watching.